Let's take a look at the reciprocal function 1 over x. The graph of it is called a hyperbola. It's one of the conic sections. And you can see that 1 over x has the interesting property that it's always moving downward. So the function description is f of x equals 1 over x. Just takes any number and finds its reciprocal. So f of 3 is 1 over 3, or 1/3. Our task is to plug this into the different quotient formula, which I've put at the top, and this time I've written it in terms of h instead of delta x because it's just a little cleaner. We put x plus h in where the x is. So the function just takes anything we give it and finds its reciprocal. So when we put x plus h in there, we get 1 over x plus h. Then from that we subtract the function with just x, the original function, 1 over x. So all of this goes in the top. That's the change in y's. And in the bottom is our interval width, which we're calling h this time. So we have fraction 1 over x plus h in the top minus another fraction 1 over x. We need to simplify that fraction. So let's just look at the top for a minute because it's kind of busy there. So just looking at the stuff that's in the numerator, if I write it out in a more vertical look, it looks like that. So that's the same thing as what's in the top up here. To simplify fractions that are added or subtracted, we have to find a common denominator. The common denominator in this case is x times x plus h. So we multiply top and bottom of this fraction by x, and we multiply top and bottom of this fraction by x plus h. So now they're both x plus h in the bottom. We've multiplied an x up there and an x plus h up there. So the result after that multiplication is that. Then we simplify that. In the numerator we're going to have an x minus an x. That's going to cancel. And then we'll have minus an h. So after we get done canceling, doing the algebra, we have a simpler formula. Now remember, this was just the top part of the big fraction here. So I'm going to take my result and divide it by h. And when I do that, this h is going to turn into a 1. It's going to be canceled out. So after doing all that work, what we end up with is minus 1 over x times x plus h. That is the formula that gives us the slope, the average rate of change over an interval. So we could pick x to be minus 1 and h to be 0.5, and we would be finding the average slope over that interval right there. If we let h go to 0, then we get the derivative. That's the slope of the tangent line at any one point. That's easy enough to do in this formula. We just replace the h with the 0 and we get minus 1 over x squared. That's the derivative. There's something interesting about that. That number, minus 1 over x squared, can never be a positive number. We already saw that the function's always decreasing. At any point, if I find the slope of the tangent line to the curve, it's always going to be a negative number. No matter where I am on the curve, the slope of that line is always going to be negative. That's because this formula can never be positive. See that? All these slopes are going down. As we go left to right, the lines are all going down, so the slopes are all negative. Now we're going to look at a different function, the square root function. We can write that as f of x equals square root x with a little radical, or we could also write it in exponential notation as x to the 1/2 power. And we'll talk more about that later, but for right now I'm just going to stick with the radical notation, square root of x. By now you should know what to expect. We take the function and plug in x plus h where we see the x anywhere, and we end up with square root of x plus h. Then we subtract the original function and divide by h. Then the trick is to simplify that, and at the end of that game we want to let h be 0 to find the derivative. Notice that we can't let h be 0 right off the bat because we're dividing by h, and you can't divide by 0 and get anything meaningful. So the question is, how do I combine the x plus h that's inside the square root with the square root of x sitting over here? That seems like a hard task. And in order to solve that problem, we're going to rely on a trick of algebra. We'd really like to get rid of the square roots. If we could get rid of the square roots, then I could just say x plus h minus x is just h, and that would be wonderful. In order to get rid of the square roots, the operation you have to do is to square. So we have something that looks like an a minus a b. And what we'd like to have is something that looks like an a squared minus a b squared. We'd like to square each of those things. We can convert a minus b into a squared minus b squared if we multiply it by a plus b. This is just a trick of algebra that's due to this fact that a minus b times a plus b equals a squared minus b squared. In this case, if we want to multiply our a minus b, that's this, that's the a minus the b. If we want to multiply that by a plus b, take a look at those two formulas. This is an a minus a b, that's an a plus a b. Of course, we have to multiply both the top and the bottom of the fraction by that. When we multiply the top, what we get is a squared minus b squared. That is, that squared minus that squared. And squaring the square roots removes them, and so we're left with the x plus h, that came from this one, minus x, which came from that one. And of course, x plus h minus x is just h. That h will cancel another h that's in the bottom, and what we're left with finally is that. Notice that we picked up some square roots in the bottom because we had to multiply the bottom of the fraction by this messy looking bunch of square root stuff. So that's still in the bottom of our fraction, but it's not too bad. This is the formula for calculating the average slope over an interval. The interval starts at x and extends to the right by a length of h. So if we pick the interval 0.2 to 0.4 on the graph, then x would be 0.2, and the width of that interval is also 0.2. The formula would tell us the slope of the line that represents the average change in the function over that interval, the slope of that line. If we let h go to 0, then we get a simpler formula, 1 over 2 square root of x, and that's the derivative. The derivative tells us the slope of the tangent line at any one point. So if we picked 0.2, or a number close to 0.2, then we don't have an average anymore. We have the exact slope of the line that's just tangent at that point. And we could calculate what that slope is by plugging in the value of this x around 0.2 into the formula. So we would take square root of 0.2 times 2 and take the reciprocal of that, and that would be the slope at that point. Here's a table that shows all the derivatives we've found so far using our quotient formula.